Hello friends, welcome again into video lecture of ADA subject. In today's video lecture we are going to learn about shortest path. In this lecture we will learn how to find shortest path between different nodes in a graph that we will learn using Floyd's algorithm. Okay, so for it we have to understand first what are the arrangement needed for the finding shortest path. So for example we will have a graph, and in that graph some nodes will be there, and in between that nodes some distance will be there. As you can see in this example, we have nodes 1 2 3 and 4, and in that node with the direction some mappings, or we can say some distance, are given. Okay, so we have to find shortest paths between all the nodes. Okay, so we have to find shortest path between node 1 and 2, shortest path between 1 and 4, shortest path between 1 and 3, shortest path between 3 and 1, shortest path between 3 and 2, shortest path between 3 and 4. So as per like we will have to find all the shortest path in our this graph. Okay, so for it we will need a matrix. That matrix will named as D. In that matrix we will store different shortest paths of our graph. Okay, so this is the description. That description we will understand by an example. Okay, so here we have this example. For this example we will have to find shortest path. Okay, so first of all we will have to create a matrix from this given graph. Okay, so for creating a matrix, some things we will have to keep in mind, that if we are calculating distance from one node to another, and between them no direct path is there, then we will have to calculate its distance as infinity. Okay, another thing is we will put 0 in case of path from node 1 and 1, means from itself it will be calculated as 0. Okay, so another distance are given into our this figure. Okay, so from this figure we will generate a a matrix. Okay, so for generating a matrix we will need 4 rows and 4 columns for these 4 nodes. Okay, so here we have this matrix. Here 1 2 3 4 are the node number, here 1 2 3 and 4 are the node numbers. Okay, so in that from node 1 to 1 distance will be 0, means for that node own distance will be 0. So here we have put 1 to 1. For going 1 to 1 we have put here 0. If we find path from 1 to 2, then here from node number 1 to 2 we have a direct path and its distance is 5. So here 1 to 2 is 5. Now for finding 1 to 3, so here node is 1 and here node is 3. So here we have a directed line from 3 to 1 but no direct path from 1 to 3. So in that case we will put here infinitive. For finding distance 1 to 4, so here path from 4 to 1 is available but no path available from 1 to 4. So in that case we will put infinitive here. Now from 2 to 1, so here from node 2 to node 1 we have a direct path and distance is 50. So here we will put 50, and from itself distance will be 0. So from 2 to 2 distance will be 0. So here notice that all the diagonal will be 0. Why? Because from distance 1 to 1 will be 0, 2 to 2 will be 0, 3 to 3 will be 0, and 4 to 4 will be 0. Okay, so same way we can write all the distance from other nodes. Okay, so in that case, if we find path from 4 to 3, then in that case here we have node 4 and here we have node 3. So we have a direct path and distance is 5. So here from node 4 to 3 our distance will be 5. So this is the matrix which is generated from this directed graph. Okay, so that is a very essential thing, that our graph must be directed, so we can write distance from one node to another. Okay, so now we will have to calculate shortest path from one node to another node. Here our first matrix D0 is, we have already calculated here, and this is that matrix, and in that matrix we have taken only direct path from the different nodes. Now we will calculate with some different node as intermediate node. For example, we will check that intermediate node with 1, means if we are calculating distance between 4 and 3, then we will put 1 as an intermediate node. Okay, so in that case our node 1 is intermediate node, so our k will become 1. Okay, so if our k is become 1, then we have to calculate different nodes distance, and we will generate another matrix and we will name it D1. Okay, so calculating D1, if we are calculating our k is equal to 1, means D1 matrix, then we will put vertices of 1 as it is as last matrix. Means if we are calculating for k is equal to 1, means k's vertices means this column and this row, one's column and one's row we will put as it is as last matrix. So we are calculating D1 here, so our last matrix is D0. So in our D0, this column 0, 50, 30, 50, and this row 0, 5, infinity, infinity, we will put as it is. Now another thing is, diagonal value will always 0, means distance from 2 and 2, distance from 3 and 3, and distance for 4 and 4 will be always 0. So we will put it at directly. Okay, now we will have to find out these 6 another nodes. So for finding distance between 2 and 3, we will take 1 as a intermediate node. Okay, so for calculating that thing, we will have a equation, or we can say a constraint, in that if we want to find our value from one node to another and we are putting some another node as an intermediate node, then we will have this formula. It says, we will understand by an example, that if we want to find out distance between 2 and 3, here distance between 2 and 3, then it will be minimum from two things. First one is distance from the last matrix, means distance from the last matrix means distance from 2 and 3. So here 2 and 3, our distance is 50. And another thing we have written here, that is dk minus 1, means our previous matrix ik means 2 to 1 plus dk minus 1 kj means 1 to 3. So here we will calculate 2 to 1 distance plus 1 to 3 distance, means 1 will be our intermediate node here. So let's find that values. So in our previous matrices, distance between 2 and 3 is 15, here 15, and distance between 2 and 1 is 50, which means between 2 and 1 is 50, plus distance between 1 and 3, distance between 1 and 3 is infinitive, so it becomes infinitive. So we will put this 15 at the place of distance between 2 and 3, so here our value will be 15. Okay, now let's find out distance between 2 and 4. So for finding distance between 2 and 4, two things: our previous distance between 2 and 4, here that is 5, and another thing is distance between 2 and 1 plus distance between 1 and 4, means intermediate node 1. So it will become, here previous distance is 5 and distance between 2 1 is 50 plus distance between 1 4, means 1 and 4, that is infinitive, so it will become infinitive. So our distance, or we can say our shortest path between 2 and 4 with the intermediate node 1 will be 5. Okay, now let's find out for 3 and 2, means shortest path between 3 and 2. So previous thing, distance between 3 and 2 is infinitive, and next is distance between 3 and 1, that is 30, plus distance between 1 and 2, distance between 1 and 2, that is 5, so 30 plus 5. So here our value is 35 is minimum, 35 is less than infinitive, so we will put 35 here. By processing same way, we can find other values for the our matrices D1. Okay, so I have already find out that values and put in this matrices, and this is our final matrices D1. Okay, so now with this D1 we have to perform another thing, that will be, we will take our intermediate node 2, means if we are finding shortest path between different nodes, then we will take 2 node is a intermediate node. In that case our k will become 2, so we have to find out our next matrix D2. So for matrices D2, if our k is equal to 2, in that case we will put vertices of 2 as it is as last matrix, means this is vertices of 2 numbers row and 2 numbers column, we will put as it is. Again understand, if you are calculating for k is equal to 2, then your 2 numbers row and 2 numbers column will be as it is as last matrices. If you are calculating D3, then your 3 numbers column and 3 numbers row will be same as its last matrices. Okay, this thing is, again diagonal values will always 0. Why? Because distance between 1 and 1, 3 and 3, 4 and 4 will be 0. Okay, so we have to calculate rest 6 values here. So we will apply our same formula that we have applied in our D1. So for finding distance between 1 and 3, we will take intermediate node 2. Okay, so our previous distance from 1 and 3, so our previous distance is infinitive, and distance between 1 and 2, here distance between 1 and 2 is 5 plus distance between 2 and 3, here 2 and 3 is 15. So in that case 20 is minimum. Why? Because this is infinitive, so 20 is minimum, so we will put our shortest path 20 here. Now let's find out distance between 1 and 4. So 1 and 4, so previous shortest path between 1 and 4 is infinitive, and another thing is distance between 1 and 2, so here that is 5, distance between 2 and 4, distance between 2 and 4, that is again 5, so that will be 10 here. So we will put our 10 here. Let's calculate for 3 1, distance from 3 and 1. So previous distance 3 1 is 30, and next with the intermediate node 2, distance from 3 to 2 is 35, plus distance 2 to 3 means 2 to 3 is 15. So in that case that will be 50. So in that case our previous distance 30 is minimum, so we will put our 30. By processing on same way, we can calculate other values of this matrix. I have already calculated and put in this matrix. So this is our D2 matrix, means with the intermediate node 2 we have calculated this matrix. So we have to calculate our D3 and D4 as well. Okay, so by processing same way as D1 and D2, we can calculate our D3 and D4. When our k is equal to 3, then we will get this type of matrix, and if our k is equal to 4, then we will get this type of matrix. Okay, so this is the shortest path between different nodes. Okay, so let's find out different shortest path between nodes. For example, if we want to go from node 1 to 3, then no direct path is here. So in our example starting, we have put here infinitive, so means we can not go from 1 to 3. But now after finding the solution of our shortest path, here we have distance between 1 and 3, means distance between 1 and 3 is 15. So here we will go from 1 to 3 in 15. Okay, so that is okay. So here let's check it out. It is 15 is correct or not. So here from 1 to 2 minimum path is 5, from 2 to 4 minimum path is 5, and from 4 to 3 minimum path is 5. So 5 plus 5 10 plus 5 15. So we can go from 1 to 3 by 15 distance. Okay, now let's check it out for another means 1 to 4. So here 1 to 4 is no direct path is available, and our calculation says the distance 10 will be minimum to travel from 1 to 4. So let's check it out. So here our node is 1, so no direct path from 1 to 4, no direct path from 1 to 3. So we have to go with intermediate node as 2. So distance between 1 and 2 is minimum 5, distance between 2 and 4 is minimum 5. So 5 plus 5 10. So this is correct. So by this way we can calculate all the shortest path of our directed graph. Okay, so this is the calculation of shortest path in a directed graph by our Floyd's algorithm. So this is the Floyd's algorithm, very simple algorithm. Here we have to put here 3 for loops. In middle for loop we are calculating our main equation that we have already performed into our matrix creation, that will be put into our J loop, that J loop will be put into our I loop, and that I loop will be put into K loop. So if we increase our K, then this thing we will have to calculate again and again. This I and J, this will make we can say 2-dimensional matrices, and k is equal to 1, k is equal to 2, k is equal to 3, k is equal to 4. That will make our d1, d2, d2 and d3, d4 matrices. So here very simple algorithm is here for finding shortest path. So Floyd's algorithm will have 3 nested for loops in it. Okay, so this is Floyd's algorithm. now as we have seen in Floyd's algorithm, three nested for loops is there: k outer loop, in it we have I loop, and in it we have j loop. So if we have three nested for loop, then obviously this will take time in order of n raised to 3, or we can say theta of n raised to 3. So analysis says that time complexity of this algorithm will be theta of n raised to 3. Okay, so this is finding all shortest path with the help of Floyd's algorithm. Okay, so this is it for this video. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you, friends.